Namaste. All right, good morning, guys. Here's what I want you to do today. I want you to do an activity. It's something that you can do at home, and it's pretty easy, and it probably won't take you all that long. Maybe about 10 minutes to actually get the data. Maybe another 10 minutes or so to do the graphs that I want you to do, and it's going to introduce the next topic that I want to teach you guys. And what you're going to need is you're going to want to get a ruler. Okay, and if you don't have a ruler, go to Google printable rulers and you can print one out, cut it out. And you're going to need a flashlight. Okay, make sure it's got batteries in it, make sure it's working. And you might be able to get away with using the light on your phone. I'm not really sure. All right, but I think if that works, fine. If not, then just try and get a flashlight. Most people have them in their house. If not, you might want to run down to CVS or something like that, or Walmart, and buy one for $2. It's probably a good thing for you to have in your house. Anyway, okay, so here's the activity. Here's what I want you to do. What you're going to do is you're going to take a flat surface. Now, I'm doing this on the chalkboard. You would want to do this on like a table. Okay, and you would also want to turn off the lights in the room and maybe close the shades, but get the room kind of dark so you can see the flashlight light better. I have the lights around here just because I'm making the video, but if I were doing this for real, I would have it dark in the room. Okay, so you can see, all right, that this flashlight is making a cone of light. I think you can see that. Yeah, you can. All right, now when you shine it directly above the surface, you get a little circle there. Okay, and you're going to measure that circle at various distances away. So you're going to start off close, and you're going to measure the diameter of the circle, and then you're going to move it away, measure it, move it away, measure it, and so on. Okay, and so you're going to get a chart going of two things. You're going to get a chart of the height above the surface versus the diameter of the circle. And then you're also going to do one more thing. Using your measurements, I want you to do a calculation, and you're going to calculate the area, the surface area of the circle. Okay, and I'll do an example for you right now. Now we're going to start off with 2 centimeters away above the surface. So, and it might be easier if there was someone in the house who could just help you out with this for like 10 minutes, a sibling or, a parent or guardian or whatever. Just grab somebody and say like, hey, I need you for like, 10 minutes or so to help me out with this activity. And so what you're going to do is I'm going to start and the reason why is because it's better you could do this by yourself, but it's oftentimes better to just have someone hold the flashlight for you, or you hold the flashlight and then measure the circle. But I'm starting 2 centimeters away from the surface, and I'm going to measure that with the diameter of the light, and I'm getting it as 2 centimeters. Okay, so 2 centimeters above the surface, and my diameter is 2 centimeters. Okay, and what would my area be? Well, the area of that cone of light, if you remember for a circle, the area is pi r squared. So that's 3.14. Now just be careful because that's the diameter. So if the diameter is 2 centimeters, the radius is 1. All right, so times 1 squared, which is just 3.14. So the area of that cone of light is 3.14 square centimeters, okay, is what I have. And then what I would do is, just to conserve chalkboard space here, what I want you to do is then move it away, and let's go in like 2 centimeter increments, works pretty well. So go to like 4 centimeters, and then measure the diameter and the area, and then do 6 centimeters, same thing, 8, 10, and you want to get like 10 good measurements. Okay, now I understand that circle is going to be a little bit fuzzy on the edges, so they're not going to be exact measurements. That's okay for this activity. All right, so what you're going to do then with this data is you're going to make two graphs, all right? And so get yourself some graph paper. And if you don't have graph paper, and by hand is actually pretty good on this. Actually, if you could graph on not Google Slides, Google Sheets or whatever, that's fine too. All right, I don't really care as long as you get a graph going. If you want to do it by hand and you don't have graph paper, then go to Google printable graph paper and print a sheet out. All right, and so what you do is do one graph, and I'll graph the height in centimeters versus the diameter in centimeters. Okay, and you're going to graph your data, and you'll want you to do a line or curve of best fit with the data. The data is not going to, if it's a line, it's not going to be a perfect line. I know what it is. I don't want to tell you. If it's a curve, it's not going to be a perfect curve. So you kind of like, do your best fit line or curve as appropriate. And again, if it looks like it's curving, then don't try and force a line of best fit in there. Do a curve of best fit. Just kind of pencil it in. All right, just like that. As Grandma Golis would say, like so. All right, so I want you to do a graph of the height versus the diameter, and then I want you to do a second graph, when you're done with that, of the height versus the area of the circle, and see if you get the same pattern or not. When you're done with that, I want you to do one last thing, okay, which is to make some predictions. So you're measuring out to like maybe 20 centimeters or something like that. I want you to predict, see if you can see a pattern on the graph. And so let's say you think it's a line, all right? And I want you to predict, okay, what you think the diameter would be at a height of 2 meters if the flashlight was 2 meters above the surface. You're not going to do 2 meters above the surface, but see if you can see any, based on any patterns you see if you can, and the word is extrapolate out to 2 meters. All right, so I want you to predict both the diameter and the area at 2 meters, the flashlight being 2 meters above the surface that you're projecting the light cone down onto. Okay, all right, and that's kind of important too, because it's an important exercise, because that's what physics equations allow us to do. And I'm going to show you a little bit more about equations later, but they allow us to make predictions about things in nature. Okay, so that's the deal with that. Where would this be useful? And you're probably saying, like, why would you ever do something like this? Well, you're using a flashlight and a ruler, and you're making a little cone of light on the surface. But the reality is, like, today we have these things called satellites, communication satellites, among other things, that hang above the Earth's surface. And what they do is they project. Sometimes it's called a footprint onto the surface. So here's the Earth, and then you have your satellite up there, and it projects, except it does it in radio waves, what's called a footprint on the surface of the Earth, so that we can bounce signals off of it and then back and things like that. So, and then we link these satellites up. Okay, so now I can bounce a signal like that, and the satellites can talk to each other, and so on, and I can go further or whatever. But so that's kind of where it's used for. Now, how do we know like how big a footprint the satellite is going to make on the surface? Well, we would have to write an equation for it, which would be the next step. We're not going to do that today. For now, just kind of do this exercise, and there you go. Okay, good luck with that, and namaste, and Golis out. Enjoy your apocalypse.